Hello everyone, this is Lab 2, Sentiment Analysis. I'm Ricardo. I'm a teaching assistant at Text Analytics class. This material is also prepared by Professor Yilu Zhou and Yifan. Today we are going to do sentiment analysis in 5 approaches, including 2 dictionary approaches and 3 Python package approaches. So we'll talk about them later. And then let's look at the file we have. We have one IPython package we have going through right now, and this is the input text. This is the same input text from last time. It is a review of a Canon camera. And we have 2 LM dictionary words. These are saved as TST files. And if you want more information and more explanations behind the mechanisms, you can go through this document. Let's get started. First, we import libraries and import our data. As we can see here, the df is the text input, and we separate them by paragraphs. So we can see data frame. We have, when we want to see the messages, and first one is the first paragraph, as we can see. This is the second paragraph, the longer one over here. The third, the second, as we can see, this one is super short, and we are wondering what kind of result the sentiment analysis could give. So it is important to know your data set before you do sentiment analysis. That's our data, and we prepare a data which is, we made it into a list, and we made it to all lower cases. It's important to understand that in the list, each object is a paragraph. So in dictionary approach, first we define a function. Over here, we don't need to understand because it's a function, and it's quite easy to understand. This is for us to, when we have a dictionary, we have a positive dictionary and negative dictionary, right? And when we input data, which I said, this data is a list. And positive dictionary and negative, both of them are also a list. When the data in positive dictionary will return into positive dictionary over here. So we'll count it as positive count. And we also count negative one, and then we subtract them. The 2 number get a net count over here. This is going through word by words to see if it is in positive dictionary or negative dictionary. So this is how the function works. And then let's include Bingliu's library. The Bingliu's library actually is imported by NLTK. You can find it over here. We import opinion lexicon. And we are asking for its positive dictionary and negative dictionary. And when we do the set, it means we remove all the repeated words. And then what are we doing here is we call for this function. We give them a list and 2 dictionary lists to see that if the list, to count how many positive numbers and negative words are matching, and then they'll give us the feedback. It is important to know that we already make sure that both of the dictionary are all lowercase. That's why it will match successfully. As we can see over here, the positive count and negative count is always integer. a positive integer. But the net count, it could be a negative one, as we see over here, and it could be 0 too. So this is a count, but this is a net count, means that this is we can, it could be negative, it could be positive, and it could be 0 too. Over here, that none of the words over here are matching with anything in the dictionary. Let's go to the next one. This is LM dictionary, which, as we see in the package we provide over here, we have negative words and positive words. Like abandon, like abnormal, abuse over here. This is a list of negative words. As we see, it all capitalized. This is, we keep it as it is when we download it. And when we see here, these are positive words from LN. Best, better, boost. So it's talking about good features. And as we go back, we see over here, we create a function called read local dictionary. And we make them, like, we remove all the space and give them all lower cases. And we make them a list. That's a self-defined function over here. So we get a list of positive words. We get a list of negative words from LN. After doing so, we call the original function again. We count positive and negative words. It will return three things, as we remember: the positive count, negative count, and net count. As we see over here, we have different results because we have different dictionary. So all of them has a kind of default problem because it's hard to compare paragraph by paragraph how intense the emotion is. We definitely can know like enough information about maybe just talking about negative thing because we match 5 negative words in LN and 1 positive word in LN. But we cannot compare them easily because this is not standardized. Some paragraphs are longer, some paragraphs are shorter. Let's try some package dictionary that we don't need to call dictionary, but we have a package to have its internal organisms. If you haven't downloaded before, you should do it. But right now, requirement already satisfied. It will show up over here. And I import it. So this time we are calling this function. We're calling for the message, so we get the original data. But this time this is not lowercase, right? We process this to the data list. We lowercase everything, but right now we don't need to get it lowercase. That's how TextBlob function. We don't need to make them lowercase. And then we call a sentiment function, and it returns polarity. So I did some research on the sentiment function of TextBlob. It returned 2 properties. Like over here, as we can see, we have polarity, we have subjectivity. In terms of this case, we use polarity because, as we see over here, subject tenses refers to personal opinion, emotional judgment. But this time we are going to analyze how people think about this camera. So it's less about opinion. We want to know more about what they think. And over here we have it will return a float, which will be between -1 and 1. So the -1 will be a negative polarity and 1 is positive. It can also be equal to 0. Let's see if the third paragraph will be a 0 or not. Over here, the third paragraph, it's a 0. So over here, we can compare them. As we can see from last time, we kind of believe the second paragraph, which is, as we see, is a very long paragraph over here. The second paragraph from here to here. And we see 5 negative words. But after its own algorithms, it show up saying that actually the first paragraph is stronger than the second one, which makes sense. And we also find that the third paragraph don't really show any emotions. So this is, we only show the hand 5, we can show hand 10. As we can see, how about hand 20? As we can see the result, it's never going above 1 and going to the minus 1. So it will always be in the range. Let's go back to our second last method. We call it Vader. It's abbreviation for Valence Aware Dictionary and Sentiment Reasoner. So you can install it when you don't. You can run this code. I won't this time. So I import sentiment intensity analyzer over here, and we assign this whole method into analyzer. So, and this code, for now, you should get used to this. We read it as for sentence in data. So for each sentence in data, we get we call it function analyzer, which is sentiment intensive analyzer over here. So we get analyzer, we call a priority scores, which is embedded function. So it returns a score, and for each sentence in data, we get a score, and the score going to our list. So scores will be the list at the same length as the data list, right? It will return 4 different entities. Over here, as we can see, there. So we have positive, negative, neutral, and negative, and also we have a compound score. This will be interesting because this is normalized weighted compound score, and as it's the same as the TextBlob result, because it's a number that between -1 and +1. So this one is a very useful matrix over here. So, and then we append this into data frame. We have negative score, we have neutral score, we have positive score and compound Vader. And over here, we can see that we get a number of compound Vaders. Some of them are positive, some of them are negative. And how about 20? Show 20 paragraphs over here. So, so we can see that some paragraphs over here are super short, and we don't really get a lot of emotions. And this one gets several by this package. So you can see this one is quite intense and it's positive. And as we can see that this 3 number is kind of a percentage. They're talking about each like negative words in terms of the whole paragraph. So they count the length of the paragraph, give them a percentage. So these of them, of the first 3 will add up to 1. And as we said, the compound number will be interesting when you do your analysis. When you're not sure about when you are not sure what's the mechanism behind this, please go to the document Uncertain Research Method. You will find the result how this compound Vader gets computed. Now this is our last package. As we talked about before, NLTK Natural Language Toolkit is a very useful toolkit for NLP, Natural Language Processing. And right now we use the sentiment analyzer inside Natural Language Toolkit cultivator. So it has similar computation, but it has different, as I assume, they have different libraries. That's why they provide a slightly different result. So this time we import from NLTK sentiment. And we call it a different name called SIA over here, Sentiment Intensity Analyzer. So we get, let's read this again. So we get the other sentence, which is, as I see in the data, it's a paragraph. But for each object in the list, we get a score. And this score actually, it has, so this score, it will show you over here. This is not only one score, it has 4 scores because it has compounded functions. So we get each one, as we see over here, it's a library. We get the key and we get the values inside. So over here, we want to get the negative sentiment, the neutral, the positive one over here. So let's keep going because this is very similar, negative, neutral, positive, compounded. It's the same naming system as you see over here. So I didn't show you the data over here. So it has the same naming system. That's why it calls in the dictionary the same way as it shows over here. And as we can see, here's our result for this time. As we can see, the third very brief sentence or paragraph over here has a negative sentiment over here. And so it also shows the result over here. But it has, let me see, different. It had different result. Let's see, 20. So definitely when you, so when I write this code, I definitely want this to be clean, but also you can do this. You can see all of them. Yeah. Okay. So we see the tell 20. So we see some of them are super short and cannot be analyzed, and there will be 0. The compounded mechanism will show a 0 too. And some of them negative, but it's also in the range of -1 and +1. So that's all our tutorial. Thank you for watching my tutorial, and have a good day.